Hello, everybody. Welcome to this class. And today we will be talking about functions in general. I would like to give you all a brief overview about functions and some basic properties. Um, and we'll also understand, we'll look at some basic examples and see how functions are useful. Okay. So, functions. A simple way to think about a function is like in the following way. Okay. It is just like a factory. So you send something into the factory, something happens inside the factory, and you get an end product. So it is like any manufacturing factory, whether it is technology, whether it is food, whether it is medicine, you give the raw materials. There are machines inside the factory which will act on the raw materials. They will make it into a finished product, and then it comes out. So this is what functions do. Okay. So functions are defined by various rules. You can define what your machine should do, and based on what you define your machine to do, whatever input you give to the machine, it will give you an output. For example, a simple machine you can say is whatever number you enter into the machine, it will square the number. Okay. So if I enter 2 into the machine, I will get 4. If I enter 0, I'll get 0. If I enter 1, I'll get 1. So it's a simple function which will just square whatever you give to the function. Okay. Now that is one thing, right? What you give to the function, what comes out as a finished product, that is there. Now the other thing which you can talk about a function is the space in which this function occurs. Like for example, are you planning to give only real numbers into the function? Do you want to give complex numbers into the function? Do you want to give integers only into the function? So all of that you can design. Okay. So this is how we define a function. We will say f of something. If the name of the function is f, okay, you can call the function whatever you want, but in general we refer to a function f. If there's another function, we say g. If there's another function, we say h. So you can call it anything. So we say f of something will be something else, and this rule has to be a generalized rule. You cannot say f of 3 will be this, f of 10 will be this. You have to decide the whole thing. For every number, what is the output? So for example, the previous example which I gave you is f of x is x squared. Simple enough, right? You give a value as an input, that is x. The function acts on this x, and it gives an output which is x squared. So let us look at that example in a little more detail. Let's say f of x equals x squared is our function. So now we can say that f of 2 will be 4. F of minus 2 will also be 4, right? F of 5 will be 25. So now we can kind of get a better understanding of how this function is working. So this is the factory version of the function definition, where you say that you give a number, you define the machine, what it should do. Here our machine f of x is just squaring the number, it gives an output. But remember the other thing I told you, you should also specify where this entire activity is going on. What if I give I to this function? If I say f of I, does it return -1 because I squared is -1? What if I return, what if I give to this function negative infinity? What does it do? What if I give my name? I say f of Raghav. Does it Raghav squared? Does that make sense? No. So we have to define along with the function where this entire activity is going on. So I will define this function f from R to R, which means whatever input I give into this function will be a real number. Whatever output I get from this function will also be a real number. I'm not allowed to give a complex number. I'm not allowed to give infinity. Infinity is not a number, it's just a symbol. I'm not allowed to give people's names. I'm not allowed to, put some picture into this function. No. The only thing I can give as an input is a real number. And I am guaranteeing you that the output will also be a real number. That's the rule. So now we can think of functions in a slightly different way. If you have one object here, you call this A. You have another object here, you call this B. A function takes things from this object and maps them to something in this object. So a function is more like a map from one place to another. For example, in this function which I defined, the f of x function, the set of all real numbers is A and the set of all real numbers is B. So basically this is starting from real numbers and it's ending at real numbers. So I'm taking objects from the space of real numbers and I'm mapping them to objects also in the space of real numbers. So I took 2 and I mapped it to 4. I took -2, I also mapped it to 4. I took 0, I mapped it to 0. Okay, so let's look at it in a little more way. So a slightly more explicit way. So now we have this is object A and we have object B. So here let's say we have some elements A1, A2, A3 dot dot dot. We don't know how many elements there are. If it's the set of real numbers, there are infinite of them. But I could say that my object A only has 10 elements, 1 to 10 or whatever. And here there are elements B1, B2, B3 dot dot dot. Okay. Now my function will map an object from here to an object from here, like this. Okay. There is a rule though. If you notice closely, this number B2, it has 2 objects that go to it, right? You can see that A1 is mapped to B2 and A2 is also mapped to B2. That is allowed. That's totally fine. What is not allowed is one object cannot be mapped to 2 different elements. For example, I am not allowed to do this. I cannot map A3 to B1 and also to B3. This is not allowed. It's not, you can just map to one object. So f of x will be only one thing. You cannot say f of x will be 3 as well as 4 as well as 5. So a simple way to look at this is I defined a function f of x equals x squared, and you saw that 1 was mapped to 1, 2 was mapped to 4, and 3 was mapped to 9. What if I defined a function in the following way? Let me say this is another function, g of x equals square root of x. Okay, and let's say I also define this function from real numbers to real numbers. Now there is a problem, because if I do g of 1, it can be 1 and it can also be -1, because 1 has 2 square roots. Every positive real number has 2 real square roots, right? Except for 0. Every positive real number has 2 real square roots. They might be rational, irrational, we don't mind, but it will have 2 square roots, one positive, one negative. So this is not a function, because if I did a map where here I have objects A and here I have object B, just let me wait. Okay, it's catching up. Okay, so then the problem would be that the number 1, 2, 3, they would be mapped to 2 things. It would be mapped to -1 and it would also be mapped to 1. So that is not allowed. So a function doesn't allow one object to be mapped to 2 different things or 3 different things. It can only send one object to another object. But you are allowed to have 2 different objects mapping to the same number. For example, the first function which I defined, the f of x function, we are having 2 being mapped to 4 because 2 squared is 4, but we're also having -2 mapped to 4. So we have both 2 and -2 going to the same number. So that's allowed. The place where they're being mapped to, we don't care. But one object can only be mapped to one number. Okay, this looks like a basic start. Now let us look at a few examples. Let's see what we can do with functions. Now let me define a function f of x equals 3x plus 5. Okay, f of x equals 3x plus 5 is a function that I'm defining, and I will define g of x to be x plus 7. Okay, now forget about the original f of x, which was the square, and the g of x, which was the square root, which was not a function, but forget that example. So now I'm defining two functions. First thing we have to check is, are these functions? Can we assure that one object will be mapped to only one thing? It cannot be mapped to two different things. No, because we know that for f of x, you're taking an object, multiplying it by 3. When you multiply something by 3, you only have one answer, right? Multiplication is a proper operation. It only gives you one answer. It's not like a square root where you get two answers. And then you're adding 5. So you will not have one object being sent to two different images. We might have two different objects mapped to the same thing. We don't know. We have to discuss about that. So let's see what will happen in this function, the f of x function. We'll worry about g of x later. Do you think that in f of x, now we are sure that one object is being mapped to only one thing, that is done. But do you think that one object can be reached by two different things, just like the square function where we had 2 and -2 both going to 4? Do you think two numbers can go to the same? By the way, both of them are from real numbers to real numbers. Both these functions are going from real numbers to real numbers. Do you think there are two real numbers for whom, if I do f of x, both of them will give me the same answer? Let's think about this for some time. Does anybody have an example where such a thing will happen, where I will have two different numbers, I do 3x plus 5 for both of them, and I should get the same answer? So let's say f of something should be 20 and f of something else should also be 20. Let's think about it for some time. Does anybody have any question? What is f of 0? F of 0 is 5. Let's see, that's sometimes a good way to approach it, because f of 0 is 5. Can we think of something else which will also give us 5? Can I do f of something else to be 5? Or let's say, what is f of 1? F of 1 is 8. Do I have anything else which has f of that number to be 8? Don't know. Okay, let's see. Let's prove that there will not be two numbers that have the same answer. Okay, let's try to prove it. I'm not sure, but let's try. So let us imagine that f of x equals f of y. X and y are two numbers, and we will imagine that f of x is equal to f of y. Am I audible now? Is my voice clear? Hello? Did the connection improve?
Yeah, you're audible.
Oh, thank you. Okay. So let us imagine. So what is the goal now? We have this f function. The function is doing 3x plus 7 for every number, right? That's our function. Now I want to show that two numbers will not have the same answer. Basically, it is allowed. So let me remind you, we are now going from object A to object B. Objects in A are allowed to be mapped to to the same object in B. That is allowed. We can have two different objects being mapped to the same number. But what is not allowed is for one object to be mapped to two different things. That we are sure that one object will not be mapped to two different things, because if you take a number and multiply it by 3 and add 5, you will not get the same answer. I mean, you cannot get two different answers. You'll only get one answer, because it's 3 times something plus 5. What we are now trying to show is if two objects will both go to the same answer. Is it possible? It's not illegal. It's totally allowed in a function. We just want to see if it will happen for this particular function. So let's assume that there are two numbers, x and y, for whom f of x is equal to f of y. So what does this mean? 3x plus 5 should equal 3y plus 5. Do you agree? So we are just applying the rule of the function. F of x is 3x plus 5, f of y is 3y plus 5. We're just trying to see if it is possible that there are two numbers for whom 3x plus 5 is the same as 3y plus 5. Now we can just use simple algebra and cancel these two 5s out, because you can take the 5 to the other side, it goes out. And the other thing you can do is you can take the 3 to the other side and cancel the 3's out. What does it result in? It says that x equals y. So basically it says that if you take two different numbers for whom this function is giving the same value, they will turn out to be the same number. So you will not have two numbers going to the same answer. It is basically the same number now. So if you imagine that there's another number which will give me the same answer, you have ultimately imagined the same number. There is no other number for which it will happen. So 3x plus 5 cannot be equal to 3y plus 5 if x and y are different numbers. Okay. So that is done. Now let us investigate the other function, g of x, which was a lot simpler. It was just x plus 7. Again, we want to check if this is a function. It looks fine because you're adding 7 to a number. Addition is a well-defined operation. You will not have two different answers when you add 7 to a number. Now we also want to check if two different numbers can have the same answer. So let us again do the same trick. We'll say x plus 7 equals y plus 7, but then that cancels out the 7, so x is equal to y. So again, both these functions are very interesting because every object is being sent to only one object. You are not having two different objects go to the same number. Okay, so that's there. That's a good piece of information for something we will learn later. Now let's see what will happen if I combine the two functions. I have f of x equals 3x plus 5, the first function. Now I have g of x equals x plus 7. What I want to do now is do something really crazy. I want to do f of g of x. So basically what I want to do is I want to take a number, I want to send it to the g factory first, which will do x plus 7, whatever. I want to take the answer and I want to put that answer into the f factory. So basically I start with the number, I apply the g operation first and then I do the f operation. So it is f of g of x. Does this make sense or is it too confusing? Let me explain with the diagram. So we start with the number x, we first do g of x, okay? So we get some answer, let's call this y, and then I want to do f of y, and then I want to get my answer. So that y is the answer we get after doing the g of x. So basically what we're doing is f of y, which is f of g of x. Does this make sense or is it confusing? Is everybody clear with this idea? Okay, thank you. So now let us evaluate. Okay, so f of x equals 3x plus 5, g of x, okay, just a second, g of x equals x plus 7. Can you all calculate what is f of g of 2, g of f of 2, and what is f of 2, and what is g of g of 2? The last one is totally crazy. You do g of 2, you get an answer, you do g of 2 for that, and then you do g of 2 for that. So let us take a few minutes and try to solve these 4 simple problems. If anybody has any question, you can ask me. Everybody else, feel free to get the answer, and you can send it to me as and when you solve it with the question number, of course. You can just send 1, 2, 3, 4 and send me the answer. Okay, I've started receiving answers already. What is f of g of 2? So you do the g of 2 first, and for that answer you do f of 2, f of that, not f of 2, f of that. G of f of 2 is you do the reverse. You first do f of 2 and then you do the g of that answer. Okay, we will wait a few minutes for everybody to solve the answer. You don't have to type the whole thing. You can just tell question number 3, this is the answer, question 2, this is the answer. You can just so okay, very good. We'll wait 2 more minutes for everybody to finish the 4 problems. Okay, so the answer to the first question is 32, because g of 2 is 9, and we do f of 9, we get 27 plus 5, which is 32. For the second question, the answer is 18, because f of 2 is 11, and then you do g of 11, you get 18. For the third question, the answer is 35. No, sorry, 38, because f of 2 is 11, and then you do f of 11. So that's 33 plus 5, which is 38. And for the last question, the answer should be 23, I think, because g of 2 is 9, g of 9 is 16, and g of 16 is 23. Okay, good. So this is called composition of functions. And the notation is not usually with all these brackets. What people do is they write it like this. They write it like this. So this means f of g. So f of g of something. If you write it like this, then it means g of f of something. So this is the short notation to write composition of functions. Okay. Okay. So let us discuss the last concept for today, which is the notion of one-to-one and the notion of onto. So the first thing, which is one-to-one, we have already discussed it briefly, but I didn't tell you that we were discussing about it. So I'll tell you what it is. So these are two different types of functions. Okay. Some functions are one-to-one, some functions are not one-to-one. Some functions are onto, some functions are not onto. So these two are not connected. So just because a function is not one-to-one, it wouldn't mean it's onto. It's like two different conditions or something. Okay. So one-to-one function, what it means is every number is mapped to only one number. Okay. And no other number is mapped to that same number. That's what it means. Just like what we had checked for that f of x thing and g of x, you will not have two different numbers being mapped to the same answer. That is the definition of one-to-one. So the example for one-to-one is this function f of x equals 3x plus 5, because you will not have two different answers being sent to the same number. If you think there are two answers which are going to the same number, they happen to be the same number, basically. So we tried doing that, right? We tried f of x equals f of y, and then we did some math and we found out that x is equal to 1. A non-example for one-to-one, something which is not one-to-one, is the function, the square function. Because both 2 and minus 2 were being mapped to 4. So it is a function, all right, but it is not a one-to-one function. Okay. One-to-one function means the mapping should be unique. One number is mapped to one thing, nothing else is mapped to that. I repeat the initial criteria. One number cannot be mapped to two numbers in any function, whether it is one-to-one or anything. You cannot have one number being mapped to two numbers. That is not there. But you can have the same number as the image of two different numbers. Like you can have two numbers going to the same number. That's allowed in a function. But that won't happen in a one-to-one function. That's what I'm trying to say. Two numbers will not have the same image. Image is basically what you get after you apply the function. So if x is the number, the image of x is f of x. If y is the number, the image of y is f of y. So what we are saying is two numbers will not have the same image. Okay, that's the meaning of one-to-one. I will give you an example and let us check if this number is one-to-one. This function is one-to-one. So let me define f of x equals 3x squared plus 8. Any thoughts? Do you think this is one-to-one, or do you think it's onto? So how do we check whether it's one-to-one or onto? We will imagine that it is not one-to-one, and we will assume that there are two numbers which have the same image, and then we will check if it is possible to have two such numbers. So let us again imagine f of x equals f of y. Okay, we'll imagine that there are two numbers x and y and they have the same image. So this is basically a proof by contradiction. We try to show this and then we fail. So then we show that it is not. Okay, so f of x equals f of y. Let's see if this is possible. So then what we would have 3x squared plus 8 equals 3y squared plus 8. If f of x equal to f of y, this is what should happen. Then what we can now do is, let me actually delete this top part so we can keep the remaining part of the proof here. Okay. So let us just continue from this. We can cancel out the 8 from both the sides. Just that is quite trivial. So then what we should get is we should have we should have 3x squared equals 3y squared, which is again just continuing from the previous step. We can cancel the 3's out. Okay. So now what this is saying is if x squared is equal to y square, then this equation is possible. When is x squared equal to y squared? Does that mean that x and y are same? No, because you can have 2 squared equal to minus 2 squared. You can have 18 squared equal to minus 18 squared. So what this means is this is not 1 to 1, because we can have two different numbers being mapped to the same thing. All we need is the numbers have to have the same square, because then the 3x squared plus 8 of that will also equal the 3y squared of 8 of some other number. So basically this function is not 1 to 1. The mapping is not unique, so to speak, because two numbers can have the same image. Okay, so that is 1 to 1. We will talk more about this next time. Obviously, this is just supposed to be an introduction where we just touch upon all these important areas. Now let's talk about onto. So I'm reminding you that there is this one object A, there's one object B, and what a function does is it takes objects from here and it maps them to here. Okay, you can have two things being mapped to the same thing or whatever, we don't know, but we are just having objects from A being mapped to objects in B. What this onto function says is that for any element in this object B, right, you take any element in that. So whether this is a set of real numbers, whether it was something that we defined, we don't know, but you take anything from that B. If a function is onto, what it means is for any number here, there will be some number in A which is mapped to that. So basically every number in B will be an image of something in A. There won't be any element left in B which is lonely. Basically it will have some number of which it is the image. The other term for that, it will have a pre-image. Image is something which you get after applying the function. Pre-image is something which is the number before the function was applied. So in our square function, if 2 is sent to 4, 4 is the image of 2 and 2 is the pre-image of 4. Okay, so without any crazy examples, let us just have this set 1, 2, 4, 8, 10. We just have this collection of numbers, and let me have another collection of numbers here. Let me say 5, 11, 13, and 0. We don't have to define what this function is doing, but let us imagine such a function exists, and let us say that 1 is mapped to 5, 2 is mapped to 13, 4 is also mapped to 13. This function, so now this function is not 1 to 1 because now two numbers have the same image. This is not allowed in a 1-to-1 function. It's still a function. Let's say 8 is also mapped to 13, and let's say 10 is mapped to 0. This is a function, totally legal function. It is not 1-to-1 because we have three different things mapped to the same thing, and it is not onto as well because that 11 person over there doesn't have a pre-image. So there is an element in B here which does not have a pre-image. 11 does not have a pre-image. We are not, for a definition of an onto function, we are not bothered about what's happening in A. Okay, we just worried about B. We want to make sure that every element in B has a pre-image, then it's onto. For 1-to-1, we are not worried about B, we are only looking at A. We want every number to be mapped to some other number. We don't want two people mapped to the same thing. So basically this 1-to-1 function focuses on the first object, that is the set of all pre-images. The onto function focuses more on the second object, which is the set of all images. So now if I did this, if I did this, and if I did this, is this function 1-to-1? It's not. Is it onto? Yes, because every number in my image set has a pre-image. 5 has 1, 11 has 2, 13 has two things coming to it, which we don't mind. We're not worried about 1-to-1, we just want onto. And 0 is also having a pre-image, that is 8. 8 is mapped to 0. So everybody here has a pre-image. So it's an onto function. It's not 1-to-1 because 4 and 10 are mapped to the same number. Okay. So this is the definition of onto function and one-to-one function. The last thing is, if a function happens to be both one-to-one and onto, so let's say that everything is mapped to a unique thing, no two people are matched to the same thing, and also everything in the image set has a pre-image, there is nobody left on the other side, then that function is called a bijective function. A bijective function is something which is one-to-one plus onto. It should be both one-to-one and onto. The previous example which I showed you was onto, but it was not one-to-one, so that is not bijective. The other example which I showed you was one-to-one, but it was not onto, so it's not bijective. So a function, for it to be bijective, has to be both one-to-one and onto. Okay. Next time we will discuss more about one-to-one functions and onto functions with proper examples. Now what we did is we just looked at some random object A with some numbers and B, and we were just looking at the diagram to check if it's one-to-one or onto. We're looking if something is left alone here or if two things are mapped to the same thing. Next time we will actually assess known functions and check which of them is one-to-one, which of them is onto, and which of them is bijective, that is both. Okay. Thank you so much and have a nice day. See you next time.